Number 8. What is the conjugate acid of each of the following? And then what's its conjugate base of each for letter D? So in this case, we have to find out what the conjugate acid and conjugate base of HS- is. Now, if you could find both the conjugate acid and the conjugate base from a single ion, like HS-, that means that in certain situations, this can act as an acid, and then in other situations, it could act as a base. So if a molecule can act as an acid and a base, that's what the meaning of amphoteric is, or amphiprotic, tomato. They mean the same thing. I know that this can act as an acid because I see that there's an H all the way in the front. Anytime that you see an H in the front of an ion or a molecule, it's going to be acidic. Likewise, if you see negative charges at the end, that's going to tell you that it could also act as a base. So since HS- has a H in the front and a negative in the back, you can tell that it can act both ways. It goes both ways. Acidic, basic. Let's just find out what those conjugates are, right? And the conjugate just means basically a pair, right? What you would make if HS- was acting as an acid or a base. So let's just pretend for now that HS- was acting like an acid in a certain solution. What would be its other, aka conjugate, base? Well, remember, a base is always just one hydrogen less than its acid. So all you got to do is just lose one hydrogen. Find the hydrogen. Here it is. And goodbye. It's no longer there. Write everything else. So there was just a sulfur. But now you just have to correct the charge. When you get rid of one hydrogen, you always minus one to the charge that you had in the beginning. Now here there was a minus, which means that it was a -1. So I bring it over here. I say, okay, it was a -1. I lost a hydrogen, so I have to -1. -1 minus 1 is -2. And that is your conjugate base. I'm just going to put con base for short. Now we have to do the same thing and pretend that HS- was acting as the acid. And let's find out the conjugate acid. So, just like we kind of said, but on the flip side, an acid is always one more hydrogen than its base. So you're going to gain a hydrogen. So there was one hydrogen here, so I just got to bump it up to 2. So instead of just saying H, I have 2 of them, H2. The S comes along for the ride, and now you just have to correct the charge. If you're adding a hydrogen, you plus 1 to the total charge, right? It was a -1, right? So I come over here and I say it was a -1 plus 1. -1 plus 1 is 0. So I don't even have to write a charge here. And this would be my conjugate acid. And those are the 2 answers. Let me know what you think, guys. This one was a little easy. These types of concepts, once you get the framework down, you guys will be golden, all right? But this is the basis for this chapter, so we got to get these down. Hopefully this helped. Let me know in the comments. Love talking to you guys. Hope you're doing well out there. And I'll see you later. Bye-bye.